Hi everybody, this is lesson 1. I think this is my favorite lesson from the ones that I'm presenting to you. This lesson is on the central dogma. So the way that you would teach this, at least the way that I would do it, is to provide the vocabulary your students will need in order to understand at least the words that are being used. Because no one really knows what DNA, RNA polymerases are, or ribosomes. So at least if you define the words for your students, they will find this activity a lot easier to do. So since most of us are not molecular biologists and most of us don't know what these words mean, this video is fantastic because it basically shows you what those words mean and what this process put together is. So let's take a look at the video and then I'll describe the lesson plan to you.
This animation demonstrates how the digital information encoded within DNA is used to direct protein synthesis. This is a DNA double helix containing the digital code which directs the cell in all aspects of operation. And here we see a protein complex called an RNA polymerase traveling down the DNA strand. As it moves down the strand, it carefully unwinds the DNA, preparing it for transcription. Inside the polymerase, we see a single-stranded copy of the original instructions being assembled as individual bases are positioned and added to the growing strand. A stop code marks the end of the protein specification, at which point this copy, known as a messenger RNA transcript, exits the polymerase and heads towards a two-part chemical manufacturing machine called the ribosome. While the messenger RNA moves towards the ribosome, transfer RNA molecules attach to specific amino acids in preparation for assembly.
Okay, so this is basically about half of the video. The video is about 2 minutes 16 seconds. So there are a couple of great things here. One, like I mentioned, these are the vocabulary words. You can describe what they are, but then this handout basically breaks up this video into multiple parts. So as you can see for part 1, what you guys saw was part 1. You basically see, what is this process called? Where in the cell does this take place? What are the goals? Is anything missing from the video? And yes, there was. But you're basically asking your students to break up this giant process, to DNA, to RNA, to protein, into smaller sub-processes. And the key here is to have them draw out these sub-processes, which is exactly what the video showed. Label those sub-processes and then go through these questions and try to figure out what they don't understand. So then eventually when you're done with segment 1, you will move on to segment 2. This is what the video just got into before I stopped it. You'll go through translation and then you can also focus on protein folding. This is great because it shows you a little bit of this in the video, but you can tie this back to something that students learned in the beginning of the class, and this would also be another great place to show a video. And then at the end, you can have wrap-up questions, and this is also another place where you can use modeling because a central dogma, of course, is a model. So not only are we using multimedia components, but we're also using inquiry-based learning in this particular lesson plan.